My name is Waldemar Schulz. I did my master in electrical engineering in the Dortmund University, where I focused on EMC as well and on high frequency electronics. And now I'm in CST responsible for EMC topics and EDA. That's why I have the pleasure today to present you our power integrity workflow. So let's start. So PDN, how to make sure we have a good PDN. One point is we have to ensure clean power, which means that we can supply our devices, which are sometimes also active components, so it won't be always clean. Another important aspect is the signal integrity. So our planes have to serve as a good reference for high-speed signals also. So it's not only our DC supply we have, but also high frequency aspects, and on the other hand the EMC limits. So we need to design a PDN which is good in terms of conducted emission and radiated emission on the other hand. Usually our PDN, all three aspects are compliant to each other, which means if we fulfill one of them well, the fulfillment of the other ones usually comes along with it. So PDN consists mainly of 4 key components: VRM, a voltage regulator, which supplies the power to all active components we have. Then capacitors, functional capacitors, but also decoupling capacitors. They help us to transport the power to our active devices. And also something which we always have is the PCB parasitic impedance. So which basically is the characteristics of our power plane. So this is something we will investigate in our PI analysis. And last but not least, there are the active devices, which are the sources of the unwanted noise we see on our power planes usually. So how to characterize a power plane? Let's start really simple. A simple power plane consists of 2 constructed solid copper layers, like you can see here. Oh, sorry. Like you can see here. And a more accurate approach, so here we only have a resistive component, 1 inductive lumped element, and a parallel capacitor which describes the capacitance, the parasitic capacitance which is created between these 2 planes. A more accurate power plane can be provided by the cascading of these lumped elements, which means we take our power plane and cut it into small areas which are characterized separately and put together in the end. So by this approach we will be accurate enough to make an accurate simulation out of it and to predict our PI performance of our plane. Something which